All right, let's dive right in. Today, we're talking about something pretty cool. The place where machine learning collides with the company's real, hard, and fast profitability. We're going to look at how these smart algorithms are jumping out of the server room and into the boardroom, making a direct impact on the bottom line.
I mean, just think about that for a second. An entire factory line just stops. A critical server goes down. A key piece of your supply chain just breaks. These things cost a fortune, right? But what if the data you already have could give you a heads up that it's about to happen, giving you plenty of time to get ahead of it? And that's not some far-off sci-fi idea. This is about using powerful predictive tech on a number that every single CEO, investor, and manager is obsessed with. So today, we're going to unpack exactly how that works.
Okay, so first things first, why are we so focused on EBITDA? Well, it's all about getting a really pure, no-fluff look at how well a business is actually running its day-to-day operations. You see, EBITDA strips out all the creative accounting and financing stuff to give you this clean signal of a company's core health. And the formula? It's beautifully simple. It's your revenue minus your operating costs. So if you want to make that number bigger, you've really only got two choices: make more money or spend less money. That's it.
Now, for decades, right, companies have been using things like Lean and Six Sigma to try and trim those operating costs. But let's be honest, as things get more and more complex, those old school methods are kind of hitting a wall. And this is exactly where machine learning steps in.
Think about it. A modern factory or supply chain creates a complete tsunami of data. You've got sensor readings, production logs, shipping data, you name it. Machine learning algorithms are built to swim in that tsunami. They sift through all that noise and find these subtle patterns, these hidden connections that a person staring at a spreadsheet would, frankly, never, ever see. So how does an algorithm actually make a company more money? It's not magic. We need a clear framework. And when you look at it from an operations point of view, ML can really pull four main levers to boost EBITDA.
And here they are. First, you can straight up reduce costs, things like energy use or maintenance. Second, you can enhance revenue, maybe through smarter pricing. Third, you can optimize your working capital. Think better inventory management so cash isn't tied up on shelves. And fourth, you can just improve productivity, getting more juice out of the squeeze from the assets and people you already have. Now this slide, this is basically a roadmap to the money, because not all ML projects are created equal. If you want the biggest bang for your buck and you want it fast, the data is crystal clear. Look at the top two: energy optimization and predictive maintenance. Both have a high impact on EBITDA, and you can start seeing results in just a few months. That's a quick win.
So, with that in mind, let's zoom in on that cost reduction piece, and specifically, let's talk about predictive maintenance. It's really one of the most proven, battle-tested ways to use ML in the industrial world today. And here's the proof in the pudding. We're talking about real-world results. Study after study shows that companies that get predictive maintenance right can slash their overall maintenance costs by 10 to 30%. That's not a theoretical number. That's a direct hit to your operating costs, which flows straight to your EBITDA. It's huge.
Okay, so we've covered the what and the why. Let's get our hands dirty and look at the how. How does one of these ML models actually turn a bunch of raw data into a prediction that saves you money? So, to make this super tangible, we're going to peek under the hood of a simple predictive model. Now, quick heads up, the example we're using is actually for predicting a company's IPO price, not for industrial maintenance. But don't worry about that. We're using it because it's a perfect, clean way to show the core process. You take raw data, the machine finds patterns, and it spits out a valuable prediction. The type of data is different, but the logic is exactly the same. So, first step, you need ingredients. For this model, the ingredients are basic financial numbers: revenue, net income, total assets. For our factory example, the ingredients would be different, right? It'd be things like sensor vibration, temperature, and how many hours the machine has been running. But the idea is identical. You feed the model the right historical data. All right, now the algorithm goes to work. And this isn't magic, it's just math. The model looks at all that past data and starts to learn the relationships. It's basically figuring out a formula. It's learning how a change in revenue, for example, usually affects a company's value, while also factoring in everything else at the same time. And then boom, you get an output. In this case, it's a predicted IPO price. And check this out, for Uber, the actual price was $45 a share, and the model predicted $45.45.
For Blackstone, it predicted $32.43 versus the real price of 31. I mean, it's not perfect, but it's incredibly close. Now, back in our factory, the output wouldn't be a price, it'd be a probability, like there's a 95% chance this motor will fail in the next 15 days.
So that all sounds incredible, but, and there's always a but, we have to talk about what happens in the real world. Because despite this amazing promise, a lot of these ML projects just fizzle out. They fail to deliver that tangible EBITDA impact. So why does that happen?
Well, there's often this huge gap between the sales pitch and the reality on the ground. We're promised this amazing accuracy. But the truth is, these models are divas. They're incredibly picky about data quality. They can also overfit, which is a fancy way of saying they get so good at predicting the past that they actually fail at predicting the future. And maybe most important of all, a perfect prediction is totally useless if it doesn't get plugged into an actual decision.
And here's where things usually go wrong. First, the data infrastructure is a mess. Garbage in, garbage out. Second, the tech teams get obsessed with how accurate the model is instead of how much money it's making. Third, the model makes a brilliant prediction and nothing happens. Nobody has the authority to actually act on it. And finally, the data scientists and the people on the factory floor don't talk to each other. So the whole thing fails, not because the algorithm was bad, but because the organization wasn't ready for it.
And that right there brings us to the single most important point of this entire discussion. After all this talk about data and models and predictions, the real secret to success has almost nothing to do with the technology itself.
Let's just let that sink in. Getting this right isn't about finding the world's fanciest algorithm. It's an operational problem. It's about having the discipline to collect good, clean data. It's about building workflows that can actually turn a prediction into a decision. And it's about getting everyone aligned to turn that decision into an action.
So I'll just leave you with this to think about. When you really get down to it, is your biggest challenge finding better math, or is it fixing what happens in the meeting room? Is the problem the code, or is it the culture?